All right, so for this video, I want to go over one of the special right triangles. And this one is all about 45, 45, those are degree symbols, 45, 45, 90 triangles. And so I said it's a special right triangle. The way you'll normally see this is with a right triangle. Right triangles have right angles. And then now we talk about these degree measurements. We know where the 90 comes from. These types of problems normally have to deal with when the other interior angles are also 40. If one of them is 45, all that's left is for the other one to also be 45, because remember these interior angles must always add up to 180. And the next thing you might realize, right, maybe I could even take this triangle and then why don't we rotate it flat like this for a second, just for a bit. And then you'll realize this is a specific type of triangle that we talked about before. It's an isosceles triangle. So we have some base angles right here. And so we've also learned that if I know the measurement of a side across from one of my base angles, the value is also the same on that other side. So if I were to say that the value of this leg over here, right, is, let's just call it 10, then that means across the other 45 is also 10. And that's going to be really helpful for us as we, keep learning and going through this with 45, 45 triangles. A lot of the time, visually, they'll give it to you in this manner. They might rotate it around. I like to present it in this kind of way. And so let's just call this side across, right? We're gonna label them a bit. So I'm gonna say this is one of the legs, right? It's not a short or a longer leg than the other one because it's an isosceles triangle. Those legs are the same, right? That's the leg and that's a leg there. And I'm referring to this, right? That leg and this leg. And then we know that across our right angle is always gonna be the longest side. That's our friend, the hypotenuse, always, right? Understanding that labeling. And so next comes a ratio, okay? A ratio of me comparing the leg to the leg to the, I'm gonna just call it height for hypotenuse. And so that ratio is, you can say it's 1 to 1, meaning those two legs have the same value. They are the same to each other. And then the hypotenuse is 1 times a root 2. Okay. This can also be seen like this. So instead of writing 1, 1, and 1 root 2, I like to use variables with it. So I can say, if this is x, this is x in a 45, 90 triangle. And then the hypotenuse then is going to be x times root 2. That is the ratio of the lengths to each other. So the legs always have the same value. They hold the same value to each other. If you are then looking towards the hypotenuse, it will have the same value of the legs, but times root 2, right? And that makes sense because the hypotenuse is larger than these legs. It'd be weird if this was x. We'd be talking about an equilateral triangle, but that's not what's going on here. And so this is the basis for understanding 45, 45, 90 triangles, but now we have to apply it to actual examples. And so why don't we start with that? We'll do an example. So I'll go to a different page here, and at the top right, I'm going to go ahead and remind myself of that ratio. This time I'm going to write it as x to x to x root 2. You might have written it as 1 to 1, and to 1 root 2. And so there's a couple different situations here. So one of them, you may be given a right triangle. There's the right angle. They say this is 45 degrees. And maybe they'll also say that your hypotenuse, actually let's start with a leg. Let's go ahead and say they give you a leg and the leg is 14. They give you no other information. So the first thing you need to make sure you understand is here's a leg, here's a leg. You can fill out this other 45-degree angle there. And then look at your ratio, right? If this side is 14 across that 45, you know that that leg right there, that missing value, is also going to be 14. Okay. What you are now missing here is your hypotenuse. And what is the value of my hypotenuse, right? According to the ratio, it is the same as the leg, but times √2. And so I can take 14, again, right? The value of my legs times √2. I can't simplify that any further. I am done. I have the value of my legs and my hypotenuse. And so there's a shortcut, right? Like, what were we given first? We were given, right? We were given a leg. What we didn't know was the hypotenuse. And so that formula is to take the value of your leg and multiply it times √2. Right? And so that's how you find a hypotenuse, right? Given legs, maybe I don't know what the hypotenuse is. Take the leg, multiply it times √2. And then, so now let's move forward to a different type of example, right? I'll scroll down. I'll give you a new right triangle. Yep, that looks nice. 45, 45, 90 triangle. And let's say I give you this leg right here. This side of the triangle right here. That is not the leg, right? I'm giving you the hypotenuse this time, right? Let's do that ratio again. Okay. Let's talk about what we're given, right? We are given the hype, right? Our hypotenuse in this case is 3√2. And what we want is the leg value, right? I'm like, I have no idea what this is worth and what this is worth. How do I find that? Our formula for that would be to take, you're doing the reverse from earlier. You're taking your hypotenuse and you're dividing by √2. And don't get confused with me writing the division symbol there. If anything, what's better is for you to say, take the hypotenuse, divide by √2. I like to write it as this ratio, as this fraction. It's a lot simpler. And so I'll show the work for that. The value of my hypotenuse here is 3√2, and I'm going to divide it by √2. And we've had a different video when we've talked about dividing radicals. If they're the same on the top and the bottom, they easily just cancel out, and that just leaves our coefficient. And so we just found that value of the missing legs, both of them, because we know that they share the same ratio, that they're identical. This is 3, this is 3. That all checks out. We can level this up to be an even harder problem, and that requires us to do a couple more steps. So why don't we go ahead and look at that? And this will probably be the last example for this video. What is a good one here? Let's go ahead and take this one. I like how this one's drawn, right? I told you that they're not always going to necessarily be, oh, that is not a right triangle. They won't always necessarily be drawn the way you like. Actually, I'll just go ahead and draw a right triangle and I'll rotate it afterwards. Much easier. So, take this. Get you a little bit confused by rotating it. Still dealing with 45, 45, 90 triangles. Right, and our shortcuts are that if I am looking for the leg, right, if I'm looking for the leg, that's a little question mark, then I take the hypotenuse and I divide it by √2, and my other shortcut is, I don't know the hypotenuse, take the leg and you multiply it times √2, right? And we'll leave those up there. It's nice to kind of remember those quick shortcuts. It's all according to the ratio, right? The 1 to 1 to 1 √2. And let's go ahead and give us something here. Why don't we say that this side over here is 5√2 over 2. And you might think, well, that's a little different, right? But let's go ahead and follow what we know. Okay, this side here is across the 45. That allows me then to fill out this other side because they're identical. So, cool. This is also 5 root 2 over 2. What I'm missing in this situation is my hypotenuse. I can look to my shortcut. I don't know the hypotenuse. Take the leg, multiply it by root 2. And I'll show the work over here. So I know that my leg has a value of 5 root 2 over 2. The formula asks me to take that, multiply it by root 2. So I'll write it as a fraction like this. Same idea. Let me multiply across. I have 5 root 4 over 2. Might think you're done. This is where your simplifying skills come into part into play, and you see, okay, cool, I have a perfect square here and I should square root that. So now you have 5 times 2 over 2, which then makes 10 over 2, which you can divide to 5. And so reminding yourself, what I just looked for was at the hypotenuse of the leg. That was our missing hypotenuse, and that's it, and that's the whole problem there. I hope that was helpful. Let me know if you'd like more examples of this. But right here, this is your best friend, right? Understanding the 1 to 1 to 1 root 2 ratio. These are your legs. This is your hypotenuse, plus this little formula right here. Hope that was helpful.